All right. Right. So can you hear me now? Is the screen visible?
Yes, yes, sir.
Okay. So what is the difference between
No,
sensitivity and
so
specificity?
the screen is not visible.
Okay. So now,
Yes.
okay. So what is sensitivity and what is specificity?
So sensitive would
So
be the
precision.
No, it's actually recall of
recall for the
Okay.
positive class,
of of positive class, right? And this is
Okay.
recall of
negative class.
negative class. And what is the
Okay.
formula for this? TP by
TP
TP
by TP plus FP.
Fn.
FN.
What is this?
TN
Tn
by
Tn plus
TN plus FN.
Fp.
Oh,
Okay. So if you have to define this, how can you define it? So this is the formula. I mean, this is just the mathematical formula. But how do you make sense out of this formula? So it is something like proportion of individuals with disease tested positive, right? So people who actually had the disease, how many were tested positive? Similarly, what could be the definition for this? Proportion of individuals. Can you complete this?
if the disease tested negative.
Without disease.
Okay.
Without
Without
disease,
disease. Yeah. Tested positive.
tested negative,
Okay.
right? So this is the interpretation of this formula. So what is sensitivity good at doing? It is good at identifying people with the disease. What does it recall do? It is good in identifying people without the disease, right? This catches people who have disease. This will catch people who do not have disease. All right. So definitely, you should know whenever we are asking question something like specificity, then you should know that we are interested in class 0 or negative class. Whenever we say sensitivity, you should know that it is for the positive class. Sometimes we don't say that can compute precision recall for class 1 class 0s, we don't say that explicitly. So whenever we say sensitivity, you should know that it is actually related to the positive class, whereas specificity is dealing with the negative class. Is it fine? This is one important thing. Next is the most important thing, multi-class problem. Multi-class. Wait, what is happening? Okay, something is happening. Okay. Let me do this in Excel for the ease of everyone. Okay. So let us say we have three classes. Let's say we have urgent, normal, and spam. Similarly, urgent, normal, and spam. Right. So these are actuals, and these are your predictions. Okay. So now let me give you the confusion matrix directly, and then let's make sense out of this confusion matrix. 5, 60, 50, 3, 30, 200. So this could be 1. Okay. Okay. So now from this, I want you to calculate precision for urgent, precision for normal, precision for spam. Similarly, recall for urgent, recall for normal, recall for spam. So this is the question. Right? Any approach you're aware of? How do you deal with this? Okay, so first let us break this down step by step. So if I say something like urgent, comma normal, which observation I am referring to?
10, sir.
Sorry?
10, the value 10.
Value 10. So this is row, this is column. So urgent, comma normal is 10. So similarly, if I say urgent, comma spam, spam, comma urgent, it is 3. Is it fine? So what does this mean? So what is the actual interpretation? So if you look first, let us look at this one. So what does this mean? This was actually which class? The actual was normal, but it was
Normal, yeah.
predicted as urgent.
Hmm.
This was actually normal, but it was predicted as urgent. Similarly, this one, this was actually urgent, and it was predicted as spam. Is this clear so far with me?
Yes.
Okay. So now our task is to predict. We have to compute precision of urgent, normal, and spam for all the levels. First, let us do for urgent. So let us say this is, as usual, I'm going to take the rows as predictions and columns as actuals. Okay. So let me call this predicted pred underscore urgent and prediction underscore not urgent. Okay. So similarly, this will be actual underscore urgent, actual underscore not urgent. Okay. So now tell me, what is the actual urgent and predicted urgent?
8.
8. Okay, fine, very good. So similarly, what is this one? Predicted not and actual not. What could this be? Think about it. So anything that is not urgent, right? This normal and spam, these two will be not urgent. So if that is the case, what would be this one?
So that would be 60 plus 50 plus 30 plus 200.
Yes, very good. So it is the sum of all these 4. That is not urgent, and that is normal and spam. Both are not urgent. Okay. So this
Yes.
is this one. So what about this one? It is actually not, but you predicted urgent.
11.
This is okay. Let me get this colors away. Right. So we said that this is actual urgent and predicted urgent, and whereas this one is actually not urgent but predicted as urgent. What about these two? These are predicted as urgent, but actually they are not urgent. 10 and 11. So if you see, these are wrongly predicted as urgent, but actually they are not urgent. Is that fine? Any question?
Oh.
So you populate 11 here. Similarly, what about this one? Right?
8.
8. Why is it 8?
Predicted not urgent, but actual urgent.
Yes, predicted not urgent, but actually it is urgent. So with this, will you be able to calculate precision? What is precision?
Yes.
For class 1, true positive by
True
true positive plus
Plus false positive.
what is
False
false
positive.
positive here?
False positive.
Hmm.
340.
340. Are you sure?
No,
Hmm.
it will be 8.
8 or 11. It cannot be 340. So it is not 8, it is 11. Tell me why it is 11. So it is actually not, but you have wrongly
Okay.
predicted it as
Okay.
urgent.
Yes.
So this is false positive. Something that is actually not positive, but you are predicting it as positive, that is false positive. Is it clear?
Yes.
Okay. So now similarly, we have to do this for the other class. Right? This is a multi-class classification problem. So second, we will do normal. This is normal. Okay. So what is actual normal and predicted normal?
10.
Huh?
10, sir.
No, wrong. Can you?
It's
Actual
60.
normal and
60.
So
oh,
predicted
sorry, yeah,
normal
60. Sorry.
and actual normal, it is
Sorry,
60.
60.
Okay. What about predicted not and actual not? It will be sum of what? Similar to the last case.
5 plus 50 plus 3 plus 200.
Sorry, can you?
Sorry, 5 plus 50
5 plus 50. No, it will be
plus
8 plus 1 plus 3 plus 200.
oh,
Is it okay?
so
Okay.
okay. This both are not right.
Yes.
Predicted is
What
also not normal and
what
actual is also
what I will do after this class, I will share this sheet with you, and you can
yes.
play around with it and understand it more in detail. You can break it down and understand it more. Okay. So now tell me, predicted normal, actually not. What are they?
Um,
50 plus 5?
5 plus 5, 50,
50.
yeah.
So this one would be 40.
Hmm.
So now what is precision of class 1? True positive by true positive plus false positive.
False positive.
It is 52%.
Hmm.
Next, for the last class, let me do this. And recall, you can do it yourself. Let us not waste time. So this is spam. This is not spam. This is spam. This is not spam. So what is predicted and actual?
200.
Sorry, 1 second. Spam and not. So this is 200. What about this one?
200.
What about this one?
That would be 8 plus 60 plus 10 and 5.
Yes,
Hmm.
beautiful, beautiful. So what about this one? So let me do it now, and you can.
So 230. Yeah.
51. So similarly, you can calculate precision recall of class 1. So this is very important. So this kind of working is called micro averaging, right? This is one versus rest. So you have one class, you treat the other two classes as rest of the classes, right? You're actually converting a 3-class problem into a 2-class problem by micro averaging. Okay, I see some question on chat. Let me see if that is visible. Okay, there are no questions. Okay, raise
Sir,
hand. Okay,
one doubt, sir.
okay.
So, sir,
So
can
once again,
I?
before you say, don't ping me on chat because I won't be able to see. I'm sharing the
No, sir, I
screen. Yeah,
didn't chat. I mean, did.
yeah. You can even if you raise your hand, I won't be able to see. Just unmute and speak.
Sir, my question is, whenever that question comes right, we have to take out the precision of this class or that class. So that
Mm.
class is considered as a positive class, right? Always. Suppose I'm saying precision of urgent. So
Mm.
here urgent will be a positive class, right?
Yes,
And
this is
rest
the positive
to
class. Rest will be the negative class.
mm,
So
same for recall, right? I mean,
yes, yes,
whichever
yes,
class you are mentioning, that is a positive class.
yes.
Mm.
So similarly, the precision for this class will be something like 0.86. right? You can calculate. So this is precision for urgent, precision for normal, precision for what is this spam. Then if you want, this is like micro averaging. So then if you want to calculate this for the entire model, if you want to calculate the precision for the entire model, not for a particular class, then what you can do is, right, let's call this as predictions. Okay, one more level down, predictions, right? Any guess how it will be? Actuals, right? So now what we are going to do is, we are not looking at an individual class, we want to look for the entire model. So prediction, let's call this yes, no, yes, no. So this will be sum of this plus this plus this. Is it correct? Yes. So now if you calculate true positive by true positive plus false positive, you will get the precision of the entire model. Okay, not just for one particular class. This is for the entire model. Is it clear? Is it clear? Can we go to the next topic? So today what we saw two things. One is specificity and sensitivity. Specificity refers to class 0 and it is recall of class 0. Sensitivity is the recall of class 1. And then we broke down this multi-class problem. We did micro averaging and then we computed precision. Similarly, you can calculate recall. How will you calculate accuracy of this model? What is the accuracy of this model?
2 positive divided by 2 positive plus 2 negative.
So today you have only this particular matrix. From this matrix, you tell me how will you calculate accuracy?
So we will sum all the diagonals and divide
Sum all the diagonal elements.
Yes, sum
Divided
all the
by
diagonal
total.
divided by total. Sum all the diagonal elements and multiplied by the total sum. That's all.
Divided by total.
Yes. So you are ready for, I mean, with this, you should be ready for your questions on, something is happening here. Let me open whiteboard again. Okay. So next we will get into data envelopment analysis. So you are ready with regard to logistic regression. So how many of you saw the videos of data envelopment analysis? How many of you didn't see? It's okay. This is not a quiz or.
Sir, wicket, right? Wicket was data envelopment.
It is 9 and 10. No, sorry, 8 and 9.
Is it 8 and 9, right?
8 and 9.
I've seen 8, sir.
Okay, so both are required, 8 and 9. If you had seen these videos of weeks 8 and 9, and after today's live session, you don't have to study DEA again for the exam, right? So what is DEA? What does DEA do? What does DEA do? It focuses on maximizing efficiency. What is efficiency?
Output by input.
Output by input. Okay. So I thought of directly taking questions on DEA, but since some of you have not seen the videos, and what I will do is I will quickly refresh the entire DEA concept, both week 8 and week 9, and then we'll take up questions, and then we'll also solve one numerical problem that is very important. So what does DEA do? It is trying to maximize the efficiency, which is nothing but ratio of output to input. Right? If you go to the theoretical part, there is something called productive efficiency. What is productive efficiency? Focuses on maximizing output under given constraints. That's all. Right? Predominantly throughout the lecture, we have taken two examples. One is 2 input and 1 output, IP1, IP2, and the other example is
2 output, 1 input.
2 output and 1 input. So let's say this is 1, this is 2, this is 3, 4 is here, 5 is here. Similarly, you have A, B, C, D, and E. So assume this is the origin. So which are the DMUs that are efficient in your diagram 1? My drawing may not be good, but the idea should be clear. Which are the DMUs that are efficient here? 1, 2, 3, or 1, 4, 5, 2, 3, 5, 1, 4, 5, and so on. What do you think is efficient?
1, 2, 3, sir. In case
1,
of
2,
input.
3. Yeah, because why is it the case?
We have to minimize the input.
Yes, because when you have constant output, so here the assumption is that we have constant output. Here the assumption is that we have constant input. So the only way DMUs can say they are efficient is by minimizing the input. Fortunately, 1, 2, and 3, so these 3 points, they are efficient frontiers. Similarly, here it is A, D, and E. These 3 DMUs are efficient, right? So what does DEA measure? What kind of efficiency it measures? Is it absolute efficiency?
So I have one question.
Okay.
So is it like there are always three of DMUs? We always take 3 DMUs as a part of the frontier, or there can be more as well. Like we could
More,
include.
There
definitely more.
can be more.
Definitely more. This is just an example to show you. Right?
No, actually, all the examples, even in the TS sessions, were shown like there were 3 as a part of the frontier. So I was confused with that.
Okay. We will not trouble you with a lot of frontiers. I mean,
Alright.
it is just an example to teach you the concept. That's all. But
Yeah, so I was just trying to understand if there could be more, like if there are more data points,
you can have thousands of DMUs, thousands.
thousands of DMUs,
Yes.
and more as a part of the frontier,
Yes.
right?
Yes.
Yeah. All right.
Okay. So
Thanks.
what kind of efficiency we are talking about here? Is it absolute efficiency? So actually DEA measures something called relative efficiency. What is relative efficiency? Okay.
So I think relative efficiency is like one DMU is not taking its own weighted inputs, but he's using other DMU's weighted inputs to increase its efficiency.
Okay. So you are partially correct, almost correct, but something can be said better. Let us take an example. So now, if you compare Sachin and Virat Kohli, so a lot of people are comparing Sachin and Virat Kohli. But it is not sensible, right? Because Sachin played in a different era. Sachin had different matches. Sachin had faced different bowlers. But is there a way by which you can compare Sachin and Virat Kohli? So Sachin had played more games. Virat Kohli has played lesser games. Virat has more runs. Sachin has maybe slightly lesser runs in ODIs or something. And let us take one format, ODI or test something. And how can we compare Sachin and Virat Kohli on a relative scale? Because if you compare them absolutely, it will be comparing apples versus oranges. You have to bring them to a common scale and then compare them and say who is efficient and who is not efficient. So what Sachin will do is, Sachin is going to pick certain, let us say there are a few inputs. So what could be the inputs for Sachin? Number of matches played, number of balls played, and so on. What could be the output? Number of centuries, number of runs, and so on. These are the outputs. So what Sachin will do is, Sachin is going to choose weights for his outputs and inputs. What are the outputs I mentioned? Hundreds and runs. What are the inputs I mentioned? Number of matches and number of balls. Okay. So Sachin is going to choose certain weights for the ball of maximizing his efficiency. Is it clear so far? Now for the same weights, we are going to look for Virat's efficiency. For the weights of Sachin, we are going to use the same weights and compute efficiency of Virat. If both are efficient, then they both are efficient. If Sachin is efficient and Virat is not efficient, for the metrics of Sachin, you say Sachin is better than Virat, and so on. Similarly, Virat will pick weights so that he maximizes his weights for maximizing his efficiency, and you can use the same weights to measure the efficiency of Sachin. Is this clear? And there is a professor at IIT Madras, Professor Srinivasan, who explicitly worked on this DEA, and he also took cricketing data sets and he computed the efficiency of Virat and Sachin, and he proved that both are efficient. Both had efficiency of 1. Okay, great. So
real data.
yes, actual data, and he built an optimization model and he proved that Sachin is efficient and Virat is also efficient, right? Okay. So, but what makes this DEA very complicated? Why is it very difficult? Because we don't have just one weight and one output. We have, we don't have just one input and one output. We have multiple inputs and multiple outputs. So here we want to see how to choose the weights so that the efficiency is maximized. So what are we trying to do here? The efficiency is nothing but U1 O1 plus U2 O2 divided by W1 I1 plus W2 I2. Right? So we are solving an LP problem, and let DMUs decide its weights with an objective of increasing the efficiency. So what are the constraints that are given? No DMU will get an efficiency of more than 1. Is it okay? Because you cannot get more than 100%. 100% is the upper bound. That's all. You cannot get more than 1. Similarly, using the weights of one DMU, other DMUs cannot get a weight of more than 1. Is it clear?
Yes.
Okay, fine. Okay. So the actual formula for this is EK is equal to Y1K O1K plus Y2K plus O2K plus Y3K plus O3K. Let's assume 3. Okay. X1K I1K plus X2K I2K plus X3K plus I3K. So what is Y1K here? What is Y1K?
The weight associated with DMUK, first weight.
Okay.
Yeah.
So here K is nothing but your DMU. What is this one? This is your first output.
Okay.
This is your second output. This is your third output. If K is equal to 1, it represents the first DMU. Similarly, this is your first input, the weight of the first input. X1 is nothing but weight of the first input. Similarly, X2 is nothing but weight of the second input. K refers to the DMU, 1 refers to the first output here. Here 1 refers to the input. That's all. So each DMU tries to maximize their own efficiency by adjusting the weights assigned to inputs and outputs. That's all. Constraint is that no efficiency can be more than 1. That's all. Very, very simple. But what is complex here? The other complexity is that it is a non-linear term. Efficiency is a non-linear term where you have a ratio of output and input. So how do we normalize this?
Denominator is equal to 1.
So you said the denominator is equal to 1, and that is called a binding constraint. So
Then
this is something like numerator by denominator. You are actually maximizing the numerator. And what do? You set the denominator equal to 1. And then comes the binding constraint that says numerator is less than or equal to denominator. That's all. So again, let me open Excel and just show you this. we'll populate small data here. So same example we'll take: sales office, then budget, then team size. We'll say one. Let's say this is 300,000, 13, 256, 500, 390. This is 14. Okay. Okay. So now, how will you formulate this? How will you formulate this?
This is one input, one output.
This is two inputs and constant.
Two input and one output.
Constant output.
Constant.
Constant output should we have not given constant output.
So output you can consider it as 1 million. 1 million is the output given to all sales offices. So the interpretation is that all sales offices are producing revenue worth 1 million, but these are their inputs, respective inputs. So here you know that everybody is let's solve it. I'm just giving the output here. Output of all the DMUs is equal to 1 million. Okay, how many?
10 lakh.
Right. Yes, this is the output. So now if I have to formulate this for DMU1, so what would be the objective function? Maximize your numerator, which is nothing but the output, which is y11 into 10 lakh.
10 lakh.
Okay. So now comes your binding constraint, where you set the denominator is equal to 1. So how will you do that? X11 into 3 lakhs
3 lakhs.
plus X21 into 13 is equal to 1. Right? This is how you set the denominator equal to 1. So then comes, what are the other things that come? So now you have to look for efficiency of DMU1, and then you also compare it to other DMUs. How will you do that? Is less than or equal to X11 into 3 lakhs plus X21 into
13. So it will be X21.
less than or equal to X11 into, what is the second input? 2,56,000 plus X21 into 9. Similarly, let me write the next one and then stop. I'm not going to do it for all the things. Okay. This less than or equal to X11 into 5 lakhs plus X21 into 7. So what is happening here? Can somebody say, I said something. I gave that cricketing example and say, why are these weights same? X11, X1 and X1 and X21, X21, X21. What are these weights? These are the weights of whom?
DMU1.
Input.
Yeah.
DMU1.
For the weights of DMU1, you are checking the efficiency of other DMUs. That's why these weights are not changing.
So first constraint is with itself, right?
You
I
are
mean,
actually setting the denominator to 1. That is what is happening here.
yeah, no, the next one, inequality constraint. This
Yes.
is with respect to its own
Yes, it's on.
value.
Yes, that's all. Right. So these are the theory part. The most important part of DEA is your numericals. Right. You have a practice assignment. Right. So here, if you take this question, for example, right, there are 6 business units. Right. There are 2 outputs and 1 input under consideration. Let's solve this question. If I can copy and paste this on the chat, you guys can have a try at this. This is very important, right? And these are you are solving an optimization problem for business unit 3, and you find that the efficiency is 0.7, which means it is not efficient. You solve for business unit 3, you look for maximizing the efficiency of business unit 3, and you see that it is only 0.7, which means it is not efficient. You find the dual variables corresponding to constraints of business unit 4 and 5 non-zero, right? So what are these 4 and 5? What are these 4 and 5?
DMUs.
For business unit 3, what is the role of business unit 4 and 5? Let's do that here, right?
So they
Binding
rely on the line, right?
Yes, let's do that. Let's take an example, right? So this could be, I'm going to take something like budget and team size. So 2 input examples, same example.
It is called frontier, right? That line.
That line.
Oh.
Okay. So here I'm trying to introduce the concept of hypothetical composite unit, right? So here we saw this example before. So here let's take the frontiers. Right? Let's call it 5, 2, and 3. Oh my God, no, this is a bad drawing, very bad drawing. So somewhere here, somewhere here. 5, 2, 3. Then let's call something here and here. This could be 1 and 4. So now we have this concept called hypothetical composite unit. So now you know that 5, 2, 3 are the envelope frontiers, right? They are business frontiers. But you know that 1 and 4 are inefficient. So how will you make 1 efficient? How will you make 4 efficient? By drawing this line from origin
2.
Right? Similarly, you draw this drawing here. Right? So here, this 1 has to come down to here. Similarly, this 4 has to reach this part of the frontier to be more efficient. Right? So similarly, in this problem, we know that business unit 3 is not efficient. How will you make business unit efficient? By going into the frontier envelopment, data envelopment. So for that, 4 and 5 are reference units. For the business unit 1 in this example, 2 and 5 are reference units. Similarly, for the business unit 4, 2 and 3 are reference units. Right? So here, for the business unit 3, 4 and 5 are the reference units. And they are non-zero, and the dual variables corresponding to other units are 0. Whereas the dual variables corresponding to these two are non-zero. And you know the value of the dual variables, it is 0.3 and 0.4. So given this information, we want to know 2 things. We want to compute that HCU. In that HCU 3, right? What would be the sales? What would be the number of leads? So how will you solve this? Let's go to Excel and solve this. you have
Sum of 0.3 plus 0.4 is equal
it's
to
sure. Good try. So it is 10,000 units, 10,000 units, and then 8,000 units, 10 and 12. This is sales. This is leads. And you know that this efficient, the dual variables corresponding to this is business unit 4, this is business unit 5. This is BU 5. Okay. You know that the dual variables corresponding to business unit 4 and 5 are 0.3 and 0.4. Right. This is the information. I have populated this on an Excel sheet. So now I want to compute that HCU3 sales. So how will I do that? What is the formula? How will I calculate that? Madam said it is
0.3 into
10,000
3 plus
10,000
plus
plus
0.4,
0.4 into 8,000.
right? Okay. Similarly for
It's U4.
HCU, there is no HCU4. HCU3
Oh,
leads.
sorry, yeah, it's U3 leads.
multiply with 10 and 12.
Okay.
10 into
So,
0.3.
so you say that it is 0.3 into 10 plus
0.4 into 12.
0.4 into 12. So this is your answer. So let us verify this answer. Okay. So look at the answer given here, 8856 to 8858. Look at our answer. So this is wrong. So where are we making the mistake?
Oh, so we have to make it efficient. So 0.3 divided by 0.7 plus 0.4 upon
Okay.
0.7 is equal to 1.
Okay. So the
So
first thing that
actual we have to multiply with 0.3 upon 0.7.
yes, 0.3
Not
divided by
directly.
yes. First thing that you have to see is the dual variables, do they add to 1? If they don't add to 1, then generally most of the time they will add to the efficiency, right? To the output. So 0.3 and 0.4 will add up to this 0.7. So now what we have to do is we have to divide this or normalize this. So now if you see, if you add up 0.3 and 0.4, it is only 0.7. So now what we are going to do is we have to divide 0.3 by 0.7. Similarly, 0.4 by 0.7. So now what are we doing? We are normalizing. So if you see, if you add up both, how much you're getting?
1.
1. So now what I'm going to do is just copy paste this. So instead of, what did I do? What did I do? Okay. So instead of, oh, I think it is correct. No. Let's do this.
It is incorrect.
Okay, let's do it. So 10,000 into 0.42 plus 8,000 into 0.57. Similarly, 10 into 0.42 plus 12 into 0.57. Right. So now these answers should match this range. Right. So when your question is, suppose in your question, if these two dual variables add up to 1, then you don't have to normalize it. Only when they don't add up to 1, you normalize and then compute the sales in HCU3 and leads in HCU3. So here what are we doing is we are actually finding these 2 points. So we say that, well, your one is not efficient, but to make one efficient, it has to sell this much. It has to create this much amount of leads. So that's what we are trying to say here. Is it fine?
So the sales we have to, what was the answer for sales?
For
8857.
8857.14. So
Okay.
if you see here,
It was the same, right?
yes, it was the same. 8857. Similarly, this is around 10.3. 8 to 10.11. So be very careful in your example. So if you change this, right, if you change this number, if you round it off somewhere, the answers will be very different. For example, let us say that you change this number to 0.42 and 0.58. So there will be some changes in the answer. So you, instead of 0.43, you make it 0.44 or something, then the numbers will change. So 90/40 is very different than this number. Your answers won't be within the range. So make this, round it up to 4 decimal places, right? And make sure this add up to 1. So if
So
at all, yes.
in exam, if we just keep it as it is, the number, then also it's okay, right? If we don't even round up.
Exams, yeah, in exams they say round up to
Yeah.
decimals or
No,
something.
decimals, like the final answer we can do.
See,
But
I'm telling you,
this thing.
I have given enough range, right? I am not very stingy person. I am not going to say that, well, it has to be this 0.1, it has to be 99.999% precise. I'm not going to say all those things. But even if you make small changes, right, instead of 0.4286, if you keep it as 0.42,
Oh, it will not come to 1. Yeah.
yeah, it will not come to 1. So make sure they both come to 1. And see,
0.43 is also correct, right?
0.58. If I do 0.58, this is 8840. But look at the answer. 8840 is not there.
No, sir. This 0.43.
Yeah, if you change it to 0.43.
And this is 0.57.
See, even if you do this, the range is very, very different. So pay attention to the numbers given there. If they say 4 decimal places, round it off to 4 decimal places so that you don't miss out on certain things. Even small numbers will make a huge difference in your answer. That is what I'm saying. 5714. So be mindful of this. Then in the last point, there is no point in arguing with this system. You can't say that, sir, I did correct, I rounded off to 2 decimal places. You didn't say. We can fight, but nobody is going to hear our arguments here because it is all automated. We cannot change the system. We cannot change the rules. So whatever decimal places we have given, pay attention to the hints that are given in the exam. Okay, so 4 decimal places, round it off to 4 decimal places and make sure they add up to 1. If suppose there could be some cases where this will be something like point, if you add up, it will be 99.99, 0.96 point something. Then you can just make sure they add up to 1 and then multiply.
Yes, it should be exactly 1, right?
It should be exactly 1. So that your answers fall in the range that we have given. So let me do one thing. I'm going to share the Excel sheets with you for your reference. I'll mail it by tomorrow. So make sure that you go through the Excel sheets and get back to me in case of any doubts in the next class. So meanwhile, you have given me some assignments, which is I have to talk to the professors and say that these small numbers, especially people who are on the verge of that threshold of 40. What is that threshold? 34.1.
34.1 rounded to 35.
I'll check with my teams and then we'll update you guys. All right.
Sure.
All right. So this is not required. I can delete this, I believe. Okay, let it be there. All right, guys. So are there any more questions?
So last few weeks are more on theoretical basis.
Yes, mostly we won't check you because we did not give you any assignments. Only practice problems were there. So therefore, we are not going to trouble you much. We only want to see your understanding on those concepts. And these are very, very difficult concepts as well. So